Hello, hi everyone. Welcome to the Student the Brand. So this is your Shiva sir. So now we will do all chapters in one video. CBSE Grade 10 Physics. All chapters in one video. So maybe it will take time. So more than 3 hours. Minimum 3 hours it will take. So be ready for it. Minimum it will take 3 hours. So be patient and listen to the class. CBSE Grade 10 Physics. There are four chapters are there. Four chapters. Those are light reflection and diffraction, human in colorful world, electricity and magnetic effects of electric current. Okay. So I'll try my level best to do all the chapters in one video. As I said, it will take time. So nearly 3 to 4 hours it will take. Some in my expectations, I'm thinking minimum 3 hours. Minimum 3 hours. Max will take 4 hours also. So we'll see. Let's continue the topic. Here, CBSE Grade 10 Physics. CBSE CBSE Grade 10 Physics. CBSE Grade 10 Physics. There are four chapters. Four chapters. First one, CBSE Grade 10 Physics. There are four chapters. Light reflection and diffraction. Light reflection and refraction and second one is human eye in colorful word. Second one is human eye in colorful word. Human eye and colorful word. Okay, and coming to third one, electricity electricity and coming to fourth one, magnetic effects of electric current. magnetic effects of magnetic magnetic effects of electric current. Okay, so these are the four chapters. Once again, how many chapters are there in CBSE Grade 10 Physics? There are four chapters. Those are you can observe here: light reflection and diffraction, human and color word, electricity, magnetic effects of electric current. Right? So now we will discuss about light reflection and diffraction. Light reflection and diffraction discuss now. So those who are new to the channel, so do like, share and subscribe to Student the Brand. So now light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Now light reflection and diffraction chapter. light reflection, and refraction, and the refraction chapter. Light reflection and refraction chapter. Okay, so here I'm taking the plane surface. This is the plane surface. The plane surface. Light is incidenting on it. So this is the incident ray, reflected ray, and this one is the normal line. So angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle of reflection. And this one is the undeviated line. Undeviated line. The angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. So reflected ray and undeviated line is called angle of deviation. Okay, so coming to laws of reflection. Laws of reflection, those are angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay, here laws of reflection. First one, the angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection means, so we can also take incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line, incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. So that is about loss of reflection. Loss of reflection. Okay. Now we will see angle of deviation. The angle between incident and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Coming to loss of reflection, incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. That is about loss of reflection. And coming to the angle of deviation formula. Angle of deviation is nothing but, so loss of reflection, loss of reflection. First one, incident ray, reflected ray, normal line. And second one, angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Now, angle of deviation equal to, so actually this is a linear angle is 180 degrees, right? Linear angle how much? 180 degrees. So that this is including angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Yes or no? Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Coming to laws of reflection, from laws of reflection, so we can write like this. Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence. So we can also write angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. Sir, why you are taking angle of reflection? So here you wrote angle of incident, here you wrote angle of reflection. How it is possible? Here you see, so in the place of angle of reflection, if you write according to laws of reflection, from laws of reflection in the place of angle of incident, if you write angle of reflection, okay, angle of reflection, so it is easy to write like this. Angle of reflection plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of reflection, and angle of deviation equal to 180 minus 2 angle of incidence. I hope it is very clear, right? Now, so this is about angle of deviation formula. Angle of deviation formula. Now, so we'll go to the another one, that is the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay, so laws of reflection, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. I hope it is very clear to you all. Right? Next one, angle of deviation formula we know. Now we will discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. Regular reflection and irregular reflection. So I'm taking here regular reflection. Regular reflection is nothing but, so incident beam is parallel, then reflected beam also parallel. That type of reflection is called regular reflection. So incident beam, so incident beam is parallel, then reflected beam also parallel. This type of reflection is called regular reflection. So regular reflection takes place on smooth surface. Smooth surface. Regular reflection takes place on smooth surface. Yes or no? Incident beam is parallel, then reflected beam also parallel. This type of reflection is called regular reflection. So smooth surface, best example we can take the plane mirror and still water. Plane mirror and still water, we can say the example for regular reflection. Coming to irregular reflection, irregular reflection, irregular reflection, irregular reflection. Okay. Incident beam is parallel, but reflector light rays are not parallel to each other. Incident beam is parallel, but reflector light rays are not parallel to each other. So that type of reflection is called irregular reflection. So I'm taking here. So these are the incident light rays. Reflector light rays I'm taking. Reflector light rays are not parallel to each other. So incident beam is parallel, but reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. Coming to regular reflection, incident beam is parallel, but incident beam is parallel and reflected beam also parallel. Okay, like incident light rays are parallel. Incident light rays are the light rays. Incident light rays are parallel. Then reflector light rays. These are the reflector light rays. So incident light rays parallel. Reflector light rays are also reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection, incident light rays are parallel to each other, but reflector light rays are not parallel to each other. Incident light rays are parallel, reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection takes place on irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Okay. And so we can take example of rough surface is wall, paper, book also we can take. Irregular reflection takes place. Irregular reflection takes place. Okay. So regular reflection and coming to irregular reflection, irregular reflection. Regular reflection, incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Here, incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. I hope it is very clear to you all, right? Yes. Coming to the object and image. So now we will discuss about object and image. Okay. Regular reflection and irregular reflection completed. Now we will discuss about object and image. Object and image. Okay. It's a real object. So how many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays. Minimum minimum 2 light rays are required to form the image of the object. Yes or no? So now, so I am taking one light ray like this. So those are reflected. Another light ray I am taking like this. Here also reflected. If we are extending those reflector light rays, if you extend those reflector light rays are meeting at one point. Reflector light rays are meeting at one point here. Okay, so now here what type of image will form? Virtual erect. Virtual image will form. Virtual image. Real object and virtual image. Real object and virtual image. Real object and virtual image. I hope it is very clear. Real object and virtual image. Now. Okay, done. Right. So one more I am taking here. Okay, from here. Real image and virtual object. Real image and virtual object. So why how you are taking like this? Because so from here light rays are coming from this point. From here light rays are coming. Okay. So this the point of intersection of incident light rays. Point of intersection of incident light rays is called real object. So if you are extending the reflector light rays, extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. So their image is forming. That is a virtual image. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Here, reflector light rays are directly meeting. Reflector light rays are directly meeting. So their image is forming. That is the real image. We are extending this incident light rays. Extended incident light rays are meeting their virtual object. Virtual object. So by this we can conclude that. That is Object and image. Object and image. Object is real, image is virtual. Object is virtual, image is real. So I hope it is very clear. Once again observe that. Here. Okay, minimal light rays are required to form the image of the object is 2. Minimal light rays are required to form the image of the object is. So minimum 2 light rays are required to form the image of the object. So from here, light rays are coming after reflection. Those are moving away from it. If you are extending this reflector light rays, extended reflector light rays are meeting at one point. Their image is forming. That's a virtual image. Here reflector light rays are meeting directly. Incident ray. So this reflector ray. So reflector light rays are meeting directly at the point. Reflector light rays are meeting at this point. Okay, so this is a real image. Reflector light rays are meeting directly. That's why it's a real image. We are extending these incident light rays. Incident light rays are meeting at one point. Extended incident light ray. Here, extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. Their virtual object. Okay. So real object, virtual image, real image, virtual object. I hope it is very clear to you all, right? Now, object and image will discuss object and image. So that is a nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror will discuss. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Now you can see here. So this is the object. Normally, if the light ray is passing along the normal line, so normally if you see, if the light ray is passing along the normal line, what happens? If the light ray is passing along the normal line, okay, so reflected ray passes in the same direction. Incident ray, reflected ray, incident ray, reflected ray, incident ray, reflected ray. Okay, so light ray passes along the normal line, reflected retraces its original path, angle of incidence is 0. Angle of incident is 0, angle of reflection is 0, angle of deviation equal to 180 degrees. Angle of incident 0, angle of reflection is 0, angle of deviation equal to 180 degrees. Because we are extending this one, right? So reflected ray and deviated line is called angle of deviation, that is nothing but 180 degrees. 180 degrees. Yes or no? Yes. So this is about angle of incidence, angle of reflection and angle of deviation. Now we will discuss one more, that is how many light rays are required to form the image of the object? Minimum 2 light rays, right? So I'm taking here one light ray along this one, here along this one it is passing. Another light ray is passing like this. After that it will be reflected back. Okay, so one more light ray is passing and it will be incidenting here and it will be reflected back. If you are extending these light rays, okay, so here we are extending these light rays and here. So if you are extending here and if you are extending here, So here image will form here. What type of image will form? Virtual image. What type of image will form? Virtual image. Here real object. So real object and virtual image. So those who are new to the channel, so do like, share, and subscribe to Student the Brand for getting more more live class, more updates regarding the uh, grade 10, grade 12, grade 11. So I already am taking the classes for grade 10 and grade 11 and grade 12. So grade 11 already yesterday only I completed projectile motion topic. Still it is there. So half of the portion, like half of the topic completed. Still it is there. So we'll be continuing. And grade 12 also classes are going to start. So like electric charges and fields will start. And grade 10. So those who want to interact with me, so you can drop any message. So and go and check the videos. So go and watch the videos of my YouTube channel. And if you are interested, if you like it, just comment in any video. I'll try to respond. So if you want to interact, if you want to need Zoom classes. So my Instagram ID is given. So in the YouTube channel, okay, go and check the YouTube channel, and you will get the Instagram link. So through that you can interact with me. I will reach to you. Okay, those who want to interact, those who want to clarify your doubts regarding CBSE grade 10, so you can interact with me, right? So daily classes will be going on grade 10, grade 11, grade 12. Okay, so if you have any doubts, you can go and check the video, enter my channel, then you will get a lot of videos related to physics. Okay, check once, right? Now you can see here. Object is real. First one is object is real. Image is virtual. Object is virtual. Image is real. Okay. So if the object is real, image is virtual. If the object is virtual, image is real. And the second point is the distance between object to mirror is equal to. So the distance between object to mirror. The distance between. So this is the object, and this one is the mirror. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. This is called image distance. Object distance and image distance. Okay. Now second point is second point. Second point is object distance is equal to image distance, and third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. And fourth one, magnification of the plane mirror is +1. Magnification of the plane mirror is +1. And coming to fifth one, it also shows lateral inversion. It also shows lateral inversion. Lateral inversion. Lateral inversion. So once again, object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object is equal to height of the image. And also magnification of the plane mirror is +1. And also it shows lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. So I will give one question from A to Z. From A to Z, which letter does not show lateral inversion? So O does not show lateral inversion. Capital letters. Capital letters. Okay, so it does not show left to right, right to left. Okay, so which letter does not show? Just check once. So O does not show lateral inversion and H also does not show lateral inversion. I'm talking about capital letters. Okay, so if you know the letters, you can check. You can comment so after the video. Okay, so you can check my Instagram channel, Instagram ID also I given. So you can go and check the YouTube channel. My Instagram ID is there. You can contact to me through that. Those who want the classes, those who want regular classes, okay, so you can check once. And blogger also there. In the comment section you can go and check the in community post. So recently like a test series I started CBSE grade 10 test series, like questions. So daily 5 questions or 10 questions are like MCQs. So daily it will be uploaded in that blogger. Okay, so you can check in that. Okay, try to answer those questions and listen to the class. So very very important concept, whatever we are discussing, all the important concepts we are discussing in the class, right? Yes, done. Now, so it's about image, nature of the image formed by the plane mirror, nature of the image formed by the plane mirror. Now we are going to discuss about spherical mirrors. Spherical mirrors. So we'll discuss about spherical mirrors. Let's start. Spherical mirrors. Spherical mirrors. Okay. That is next one. Spherical mirrors. The mirror which is in the form of the mirror which in the form of curved shape, that is called spherical mirror. The mirror which in the form of curved shape, that is called spherical mirror. So I am taking like this. Okay, so if you are taking the small portion, that is called curvature. If you are taking the small portion, that is called curvature, right? So depending on the reflection of light, spherical mirrors are divided into two types: concave mirror and convex mirror. Concave mirror and convex mirror. So now you can see here, concave mirror, concave mirror. So pole, focus, center of curvature, pole, focus. Actually, these points we need to discuss. Chalo then. First we'll work out. So we'll discuss only concave mirror and convex mirror. Concave mirror and convex mirror. So this is the concave mirror. Concave mirror. The mirror whose reflection takes place inward. The mirror whose reflection takes place inward is called concave mirror. Okay, the mirror whose reflection takes place inward is called concave mirror. Okay, concave mirror is also known as converging mirror. Converging mirror. Converging. Converging mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Convex mirror. Convex mirror is also known as diverging mirror. So second one is convex mirror. Convex mirror. Convex mirror is also known as diverging mirror. Diverging mirror. Convex mirror. So concave mirror is known as converging mirror, whereas convex mirror is known as diverging mirror. Sir, why you are telling concave mirror is a converging mirror, convex mirror is a diverging mirror. Because whenever light rays falls on it, after reflection, the light rays are moving towards the principal axis. After reflection, light rays will move towards the principal axis. Means coming closer, converging. Mirror is converging the light rays. Here, after reflection, light rays are moving away from it. After reflection, light rays are moving away from it. Okay, after reflection, light rays are moving away from it. That's why it is called diverging mirror. So convex mirror is also known as diverging mirror, whereas convex mirror is also known as converging mirror. I hope it is very clear. All right. Now, so this is about concave mirror and convex mirror. So now we will discuss about ray rules. Ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. So before that, we will discuss about terms related to spherical mirror. Terms related to spherical mirror, spherical mirror. Spherical mirror. Now we will discuss about spherical mirrors. Chalo then. So the mirror which in the form of curved shape is called spherical mirror. Spherical mirror. Okay. So terms related to spherical mirror. So I am taking the concave mirror like this. So this is a part of the sphere. So this is the center of the imaginary sphere in which mirror is a part. C is the center of the imaginary sphere in which mirror is a part. So P is the pole. P is the pole. C is the center of the imaginary sphere in which mirror is a part. P is the pole. Line joining of center curvature and pole is called. Line joining of center curvature and pole is called. So center curvature, pole, and third one is principal axis. Actually, I am taking the concave mirror. Okay, so concave mirror I am considering. So, right. So center of the imaginary sphere in which mirror is a part. So pole is the midpoint of the mirror. The line joining of central curvature and pole is called principal axis. Principal axis. Okay. And coming to the fourth one. So the distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. And coming to that, after reflection, light rays are meeting at one point. After reflection, light rays are meeting at one point. That is called focus. After reflection, light rays are meeting at one point. Actually, that point is called focus. That point is called focus. So this point is called focus. So after reflection, light rays are meeting at one point, right? After reflection, light rays are meeting at one point on the principal axis. That is called focus, principal focus, simply called focus. And sixth one, the distance between focus to pole. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Okay. This distance, the distance between focus to pole. So focus to pole is called focal length. So this distance is called focal length. And the seventh one, width of the mirror is called aperture. Width of the mirror is called aperture. Width of the mirror is called aperture. Once again, center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. The line joining a center curvature and pole is called principal axis. The distance between center curvature to pole is called radius of curvature. After reflection, all light rays will meet at one point of the principal axis called focus. The distance between focus to pole is called focal length. So the width of the mirror is called aperture. Width of the mirror is called aperture. I hope it is very clear. Right? Next. So we'll discuss about ray rules are spherical mirror. Ray rules. Ray rules. So ray rules, concave mirror and convex mirror, two mirrors, ray rules we'll discuss. So similar only. Okay, if you know the concave mirror, we can get to know the convex mirror. So concave mirror, next one convex mirror. Convex mirror. Coming to concave mirror, first one, so pole, focus, center of curvature, pole, focus, center of curvature. One light ray is taking after reflection passes through focus. Second one, so pole, focus, center of curvature, right ray is passing through focus. After reflection passes towards infinity. So here light rays after reflection passes through focus, light ray is passing through focus, after reflection moves towards infinity. Okay, moves towards infinity. Coming to the next one, third one. Here light ray is passing through the center of curvature, pole, focus, center of curvature, right ray is passing through center of curvature to reflect back. And coming to the fourth one, light ray is incidenting at the pole. Light rays, so this is the pole, focus, center of curvature, light ray incident at the pole, it reflect back. So these are the four ray rules. Coming to the convex mirror, convex mirror. First one, so pole, focus, center of curvature, light ray is passing parallel to the principal axis. After reflection passes through the focus. It passes through the focus. Second one, so pole, focus, center of curvature, light ray is passing through the focus. After reflection moves towards infinity. Coming to the third one, so pole, focus, center of curvature, light ray is passing through the center of curvature. Okay, so it retraces its original path. Coming to the fourth one, light ray is incident at the pole. Light ray incident at the pole. Okay, so this is the pole, focus, center of curvature. Light ray incident the pole, it reflect back. Okay, so these are the ray rules of concave mirror. Ray rules of concave mirror. Okay, so this is about concave mirror and convex mirror. Concave mirror and convex mirror. Ray rules. Coming to the image formations, we'll discuss about image formations. Image formations. Image formations we'll discuss. Image formations. Concave mirror image formation. Concave mirror. First one. So pole, focus, central curvature. Object is at infinity. Object is at infinity. So if the object is at infinity, light rays are coming parallel to the principal axis. So here object is at infinity. So here I'm taking, after reflection, light ray passes through focus. Object at infinity, image is forming at focus. Nature of the image is real and inverted. Highly diminished. Real and inverted and highly diminished. Coming to the next one. Object is placed beyond center of curvature. So pole, focus, center of curvature. Object is placed beyond center of curvature. How many light rays are required? So minimum 2 light rays, I said, no? So minimum 2 light rays are required to form the image of the object, right? So I'm taking here one light ray. It passes like this. Another light ray passes through center of curvature. The image will form between C and F. Object is placed beyond C. beyond C. Image will form between C and F. Nature of the image is real and inverted, and size of the image is diminished. Size of the image is diminished. Okay, coming to the third one. Third one. Object is placed at F. So object is placed at C. This time object is placed at C. How many light rays are required? Minimum 2 light rays, right? So I'm taking object at C. Object at C, image also will form at C. Nature of the image is real and inverted. So same size. Object is placed at C, image also will form at C. Nature of the image is real and inverted and same size. Coming to the fourth one. So pole, focus and center of curvature. Pole, focus, center of curvature. Object is placed between C and F. Object is placed between C and F. How many light rays are required to form the image of the object? Minimum 2 light rays. So one light I am taking like this. After that passes through focus. One light I am taking, incidenting at the pole, it reflects. Image will form between C and F. Object is between C and F. Image will form beyond C. Beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased, that is enlarged. Okay. So that's about, these are the 4 image formations. So 2 more are there. So we'll discuss 2 more image formations of concave mirror. So 2 more image formations. So next image formation is object is placed at F. So object is placed at F. So pole, focus, center of curvature. Object is placed at F. One light I am taking like this, passes through focus. Another light ray incidenting at the pole, it reflects back. Object is at F. Image will form at infinity. Object is F, image will form at infinity. Nature of the image is real and inverted and highly enlarged. So fifth one. Coming to sixth one. Sixth one is very important. Six image formation is very important. So just focus on it. That is. So here I am taking. So pole, focus, center of curvature. Object is placed between F and P. Object is placed between F and P. How many light rays are required to form the image of the object? Minimum 2 light rays, right? So here I am placed. So one light ray I am taking like this. It passes through focus. Another light ray incidenting at the pole. It reflects back. So if you are extending these light rays, those light rays will meet here. Okay. So image will form here. Object is placed between F and P. Image will form behind the mirror. Behind the mirror. Nature of the image is virtual, erect and enlarge. Virtual, erect and enlarge. Virtual, erect and enlarge. I hope it is very clear. Right? So this is about image formation of concave mirror. So we'll take break. Okay, we'll take break. Then we'll continue in the next class. Still so many points are there. So we'll discuss. Thank you so much. Those who are new to the channel, do like, share and subscribe to Student the Brand if you like the content. So you can share it to your friends, ask your friends to join to the class. Thank you. Thank you so much.